Bismillahirrahmanirrahim. So today we will discuss about differentiation, basic rules of differentiation like derivatives. Uh, let's start. First of all, first rule is state that if we take the derivative of a constant number, that will be equal to zero. Derivative of a constant number is always zero. We have some examples like uh, what is constant function? We know that a function something like that. If we change x, answer will be same. So in the same way, see that 8 is a constant function. We can write it as f of x is equal to 8 like that. So that is why its derivative 0. Y is also a fixed number constant. Its derivative will be 0. E raised to power 4. This is also a constant number. That is why its derivative equal to 0. So this is the first rule. Like if we take the derivative of a constant number, that will be equal to 0. Second rule is a power rule. Like this is a generalization. It also a generalization of power rule. This one, like it state that for any real number, if you have a dx u raised to power n, it will be equal to n time power will become coefficient, decrease one in power, and take the derivative of base. Right? Keep in mind, if you have u raised power n, this is your base, and this is your power. So the rule state that power will become coefficient, decrease 1 in power, take the derivative of base again. In particular, if u is equal to x, then see that it will become uh, again power coefficient, decrease 1 in power, and derivative of x, we know that we take the derivative of x with respect to x, that will be equal to 1. That is why this part become equal to 1 in this case. So in particular case, if u is equal to x, then power rule is something like that. After this, we apply this, like we try to find the answer by using this power rule. See that here power is 3, so power will become coefficient, decrease 1 in power, and take the derivative of base, because no need to take the derivative of base, because in this case derivative of base will become 1. So it will be 3 times x raised to power 2. Same, we have need to apply power rule here. Power will become coefficient, decrease 1 in power, and no need to take the derivative of base, because derivative of x, we know that derivative of x with respect to x is equal to 1. So it will be 1 by 2 x raised power, we know that 1 by 2 minus 1. When we take the LCM, it will be equal to 1 minus 2 over 2, that will be equal to minus 1 by 2. And this can also be written as 1 by 2 x raised to power 1 by 2. In the same way, for example, if you have any other function like uh, d by dx and x plus 1 raised to power something like that. So how we will do this? Same, if we want to apply, like in this case, see that base is not equal to simple x. So in this case, we apply power rule like that. Power will become coefficient, then decrease 1 in power like 2 minus 1, and take the derivative of base. Base is in this case x plus 1. So in this way, our answer will be 2x plus 1, and derivative of x with respect to x will be 1. Derivative of derivative of x with respect to x1, and derivative of constant will be equal to 0. So final answer will be equal to uh, 2 times x plus 1. This is the answer. In the same way, next rule is constant multiple rule. Like if you have a function, any function, and any constant multiply by here, so what we will do, how we will find the derivative of this function? So in this case, uh, constant will be out, like you can see that, you can say that like that. Constant will be out, take the derivative of function, and derivative of this function can be written as then f prime of x, 2 times f prime of x. For example, in this case, see that 5 will be out, take the derivative of x raised to power minus 6. So in this case, this will become, when we find the derivative of this one, what will be the answer of this one? Power will become coefficient, we apply power rule. Decrease 1 in power, so we decrease 1 in power. We would take the derivative of base again, like derivative of x with respect to x will be equal to 1, so that is one you need to take. So in this case, 5 multiplied by minus 6 will be equal to minus 30, and x is power minus 7 is the answer. In the same way, again, what we will do, constant will be out, just take the derivative of function is here x is power 2 by 3. So if we now what we have need to do, C will be as it is, apply power rule on it. So power will become coefficient, decrease 1 in power, and derivative of base will be equal to 1. So in this case, see that 3 will be cancelled out 3. So 2 times x is power, when we take the LCM, 2 by 3 minus 1 will be written as 2 minus 3 by 3 minus 1 by 3. Means that x is power minus 1 by 3, which can be written as 2 over x is power 1 by 3. This is the answer. So after that, we have fourth rule, that is sum difference rule. Like if you have two function in uh, added together, like that, how we find the derivative of it. And if two function subtracted to each other, what will be the derivative of these functions? So in this case, what we will do, we will take the derivative of individual function and add together. Like we apply the derivative on each. It will be like next step will be something like that. D by dx of f of x plus d by dx of g of x. That can be written as like that. In the same way, a derivative will be applied on each function individual. And after that, this will be something like that. Now, if we want to take like, see that this is something same like that, two functions are added together, right? We consider that this is f of x, this is g of x. So what we will do, we will apply the derivative on each. And then first one, we apply the power rule, power coefficient, decrease 1 in power. And second one, we know that derivative of x with respect to x is 1. How? See that. Again, like if you have x as power 1, you know that power coefficient decrease 1 in power. So it will become 1 time x as power 0. That will be equal to 1 time any number raised to power 0 is equal to 1. So that will be equal to 1. So that is why whenever keep in mind we have derivative of x with respect to x, that always equal to 1. Directly you can say that. So that is the answer. You can make more simplification, something like that. 2 times x plus 1. In the same way, same if you have some difference, something like that, again you have need to do same. First take the derivative of this, minus will be as it is, take the derivative of this, plus will be as it is, take the derivative of this. So derivative of this function, we know that 2 will be out, and derivative of we will take x as power 9. In between negative sign, derivative of x. In between plus sign, derivative of 3. So that will be 2 times. Now we apply power rule on it. So by applying power rule, we know that power will become coefficient, right? Power become coefficient, decrease 1 in power. And if we take the derivative of base, that will be 1, because derivative of x with respect to x is 1. And same derivative of x with respect to x1, derivative of a constant is 0. So in this way, what will be the answer? 2 multiplied by 9 will be 18. X is power 9 minus 1 will be equal to 8, and minus 1. This is the final answer. Now next one, we have a product rule. So product rule, like when you have two function in a product form, then how we will find the derivative of these two functions? For this we have a rule like product rule. So see that what state that you will keep g of x as it is, take the derivative of f of x, and in between plus sign, f of x as it is, take the derivative of g of x. So there is no problem, like if either you will write something like that, because it's a addition and we know that commutative property hold in addition, right? So there is no issue. Like either you choose this one f of x first function and this one second function. So first write second function, first function derivative in between plus sign, then first function take the derivative of second function. So see that again we have two function in a product form here. So what we will do, we will write, like we can consider either one f of x or t of x, because we know that in addition commutative law hold, like 2 plus 3 or either 3 plus 2 both give us the answer 5. So that is why if you write this term first or this term first, it will not affect your answer. So say that first of all, like g of x will be as it is, 2x is power 3 minus x will be as it is, and take the derivative of 2x is power 2 minus x, like that. Then in between plus sign, 2x is power 2 minus x will be as it is. Now take the derivative of g of x, like 2x is power 3 minus x, something like that. So derivative, this one will be as it is, and derivative of this one, we know that for taking the derivative of this term, derivative of 2x when we apply, like 2 will be out, and when we apply power rule it will be 2 times x, because 2 minus 1 will be equal to 2, and derivative of x will be equal to, minus will be as it is, 1. Then in between plus sign, and next you can see that this will be that function will be as it is, like 2x square minus x, and now we will take the derivative of second term, that is like this one. So 2 will be out, and derivative of x cube will be 3 times x square, right, when we apply power rule on it. And derivative of x will be, minus will be as it is, derivative of x will be equal to 1. So in this way, final answer will be something like that, like 2x is power 3 minus x times 2 multiplied by 2 will be 4x minus 1 plus 2x square minus x. Now 2 multiplied by 3 will be equal to 6x square minus 1. So this is the answer. And if you want to simplify, that's up to you. Like if you see that something is common, you can take, and if you want to multiply this to this or something like that, this is up to you. By the way, this is the way out how we will apply product rule. So whenever you have two function in a product form, this is a way out. Either any two function, let's say if you have d by dx x minus 1 or x square plus 1. So same you have need to do. Here you will apply product rule, because two function in a product form, what you will do, like x square plus 1 will be as it is, take the derivative of x minus 1 in between plus sign, then x minus 1 will be as it is, take the derivative of x square plus 1. So what we will get, x square plus 1 as it is, and derivative of x 1, derivative of constant 0 plus x minus 1, again derivative of x square, when we apply product rule that will be 2x, and derivative of constant will be 0. So final answer will be x square plus 1 times 1 plus x minus 1 times 2x. So see that in this case you can make simplification, 2x square, when we multiply 2x with here, minus 2x. So finally we will get 3x square minus 2x plus 1. So this is the answer, like derivative of x minus 1 times x square plus 1. So this is the way out whenever you have a two function in a product form, or you will apply product rule. After this, uh, like if two function have product form, you apply product rule. But what about if you have two function in a quotient form, like in a quotient form, like ratio of two functions? What you will do, how you will find the derivative of these two functions? So for this we have quotient rule. Like if you have two function in a quotient form, like ratio form, then you will apply quotient rule. This is not necessary both are rational, like both upper and lower polynomial, it will be any function. Okay, so for this what we will do, like for example this one, we can say that we know that this is a numerator and this is a denominator. So what we will do for this, like if you have two function in a quotient form, like lower function denominator function will be as it is, take the derivative of upper function, this one upper function, then upper function will be as it is, take the derivative of lower function, and divided by, take the square of lower function, and in between negative sign. This is important, and keep in mind, if you if you write something like that, f of x g prime of x minus g of x f prime of x over gx whole square, like you say that this is a quotient rule, so that will be considered as wrong, because we know that commutative law not hold in a subtraction. 2 minus 3 or 3 minus 2 both are not equal. Why? See that this will be equal to minus 1, this will be equal to 1. So that is why upper function, first of all, you have need to take the derivative of upper function. This is very important. What we have need to do, again keep in mind, lower function as it is, derivative of upper function, then in between negative sign, not positive sign, and then upper function as it is and derivative of lower function, and in denominator it will be a square of lower function. So let's start. Let me take the derivative of this one by applying quotient rule. Why we are going to apply quotient rule? Because it is a this is given in a ratio form, right, in a quotient form. So what we will do, this is not negative, it's a bold point. So see that what we will do in this case, upper like lower function as it is, right, and then we will take the derivative of upper function. Upper function here is x minus 1, like this will be considered as our f of x in this case, and this will be considered as our g of x, and we are going to apply this formula. So by this formula, lower function as it is, take the derivative of upper function in between negative sign, then upper function will be as it is, upper function is x minus 1 times the derivative of lower function. Derivative of lower function, that is x cube plus 1, and then divided by lower function square, like x cube plus 1 raised to power 2. After that, what we have need to do, we know that like this will be x cube plus 1, and derivative of x in this case, derivative of this x will be equal to 1, and derivative of constant will be equal to 0, minus x minus 1 time derivative of x cube will be equal to 3xk by power rule, and derivative of constant will be 0, divided by x cube plus 1 raised to power 2. So in this case, what will be the final answer? X cube plus 1 into minus 3x square x minus 1 over x cube plus 1 whole square. If you want to simplify it, that's up to you, like by multiplying this and this and open the brackets, that's up to you. But this is a way out how you apply a quotient rule. Like if you have two function in a product form, you apply product rule. If you have two function in a quotient form, like ratio form, then you apply a quotient rule. After that, like if you have two function in a composition form, then you apply a chain rule. Like function, you have a function f of x, and inside again you have a function, then you apply chain rule. So in this case, what will be happen? It will be something like that: derivative of outer function uh, times the derivative of inner function. Like if you have d by dx of f of g of x, so it will be derivative of outer function time the derivative of inner function g prime of x. For example, by example you will understand better. See that this is the inside also we have function. So first of all, what we will do here, we apply power rule, like chain rule here. We state that derivative of outer function. So if you see that this is a composition, like x raised to power 5, and other one, for example, if this is f of x, so in this case g of x is something 3x plus 1. So if you make the composition f of g of x, you will get what? You will get 3x plus 1 raised to power 5. So in this case, see that very simple. First of all, take the derivative of outer function, that will be 5, 3x plus 1 raised to power 5 minus 1. And then take the derivative of inside function. Inside function is 3x plus 1. So in this way, what will be the answer? It will be 5 3x plus 1 raised to power 4. Derivative of 3x will be equal to 3. Derivative of constant will be equal to 0. So after simplification, 3 multiplied by 5 will be equal to 15. 3x plus 1 raised to power 4. Here is plus 1, not just plus. So this is the answer. In the same way, like any other function, you have two, like if we take any other example, like for example, mm, if you have something function something like that, x square plus 1 raised to power uh, minus 4. So in this case, again, we will apply chain rule, which state that minus 4 times x square plus 1 raised to power minus 4 minus 1 by power, by chain rule. We apply here power rule. Because we take the derivative of outer function, then we will take the derivative of inner function, that is x square plus 1. So in this way, it will become minus 4x square plus 1 raised to power minus 5, and derivative of x square will be equal to 2x, derivative of constant will be equal to 0. So 2x multiplied by 4 will be equal to minus 8x times x square plus 1 raised to power minus 5. So this is the final answer. In the same way, like if you have this all that what we have need that what we have done yet now is that all about the algebraic functions, right? But we have some other types of function like exponential functions. We know that this is a function something like that, a raised to power x, or you can say that b raised to power x or e raised to power x, a function in which, what is exponential function? We know that a function in which power appear as a variable. So this is called as, and keep in mind this is a constant. This is a constant. This is a constant. So in the same way, 10 raised to power x, 2 raised to power x, e raised to power x is a Euler constant, right? So these type of functions are called as exponential functions. So how we will find the derivative of this type of functions? For this, it's a very simple rule. Like if you have exponential function, it is e raised power f of x, then it will be take the derivative. Then how we will find the derivative? Take the derivative of this power here and then multiply function whole as it is. Right? For example, if you have need to take the derivative of e raised to power, let's say just 2x. So what you will do, take the derivative of 2x, like power here is 2x, right? So take the derivative of power 2x, that is equal to e, like something like that, and multiply function as it is. So that will become, derivative of 2x will be equal to 2 and it will be raised power 2x. In the same way, like if you find the derivative of e raised to power x, so that will be equal to, derivative of power will be equal to 1 and it will be equal to e raised power x. This is very important. Like this is a function whose derivative is itself. So this is a way out. Now we will do some example, then you will understand better. For example, this is called as, actually if you have e raised to power f of x, this is called as natural exponential function. Like if this base is e, then it's natural exponential function. This is a general. So in the same way, we apply the above rule. So we need to take the derivative of this term, like power, that is 2x square minus x, time this whole function as it is. So derivative of this one, like 2x square, we know that 2 will be out. Derivative of x square by power rule, this will be 2x minus derivative of x will be equal to 1. So in this way, this will be as it is, 2x square minus x. So final answer will be 4x minus 1 time e raised power 2x square minus x. So this is the answer. In the same way, like if you have base other than e, so what we will do in this case? In this case, like if you have base other than E. So again, same rule, just one thing added, ln a, like f prime of x ln of a f of x. For example, if you have function something like that 2 raised to power x square. So by above rule, what will be happen? We need to take the derivative of power. So derivative of x square, we know that will become equal to 2x time ln of a. Here a is equal to 2. So ln of 2 time function as it is. So 2 raised to the power x square as it is. So this is the final answer. In the same way, like if you have need to take the derivative of d by dx of a raised to power x. So what will be the derivative of this one? This one, like same derivative of x with respect to x will be equal to 1 times derivative of x with respect to x 1 times ln of a times a raised to power x. So that will be ln of a raised to power x. In the same way, like if you take the derivative of 2 raised to power x, that will be equal to ln of 2 times 2 raised to power x. This is the way out how we will take the derivative of exponential function if base other than e. Same, like if you want to find the derivative, same what we will do, find the derivative of function power, then ln of a, in this case a, yes, a itself, and function as it is. So derivative of x cube minus x plus 1 will be equal to 3x square. Derivative of x, like minus as it is 1, derivative of constant will be 0. Then ln of a times function as it is, a raised to power x cube minus x plus 1. So in this case, final answer will be 3x square minus 1 times ln of a raised to power x cube minus x plus 1. So this is the way out how we will find the derivative of exponential function. We have two type of exponential function, one in which base is Euler constant e, and other this is like that. Actually this is a general rule, like in this, if a equal to e, we will get this formula. You can check it out because we know that ln of e is equal to 1. So at that point one will get ln of e, that become a, and we will get this formula. So two formulas you have need to keep in your mind for finding the derivative of exponential function. After that, like we have need to find the logarithm of derivative of logarithmic function. We know that logarithmic function is, there are two type of logarithmic function. One is like, first of all, logarithmic function can be written as log of here a and something here, it will be a sum, let's say x for the time being. So there are two type of logarithmic function. If here a is not equal to e, like it will be a 2 3 something else, so this will be written as log of you can say that general a f of x, right? But if you have a is equal to e, so your function f of x will be something log of e time x, can be written as ln of x. This is called as natural log. And if a is equal to 10, this will become common log. Here fx, I put here fx. You can say that for if you keep x for the time being, there is no problem. So it is called as natural exponential function. So sorry, not natural logarithmic function. So one is natural logarithmic function, other is uh, common log or any other. Like if base is 10, then it will be log 10, log base 10 and x. So this will be called as common log. So for this we have two functions. For this we again have two formulas to find the derivative. Like if you have d by dx uh, log of a is not equal to e, and here f of x be any function, then how we find the derivative? The derivative of this one will be equal to 1 over f of x times ln of a and derivative of f of x above. So this is the formula. This is the first formula if a is not equal to e. So see that. And in the same way, if a is equal to e, then it will become actually ln of f of x. So its derivative will be something like that. Derivative of f of x divided by f of x. In this case, actually, we know that ln of a will become equal to 1. So these are the two formulas that we will use when we need to take the derivative of logarithmic function. For example, we take some example, then you will understand better. For example, if we have need to find the derivative of log of 5, here we have function x square plus 1. So what is the way out? Here f of x. What is f of x? F of x, here you can see that this is f of x. So first of all, derivative of f of x on top. So it will be 2x plus 0 divided by, like numerator, we write the derivative of f of x and divided by f of x times ln of this base is 5. So answer will be, in this case, our answer will be 2x over 2x square plus 1 times ln of 5. In the same way, like if we have need to take the derivative of log of 10, and for example, here you have any function, let's say 3x square minus 2x plus 1. So again, what is f of x here? F of x is this function, like this thing. So in this case, derivative of f of x on numerator. So derivative of 3x square, we know that this will be 3 times. When we apply the power rule on x square, this will be 2x minus derivative of 2x will be equal to 2 times 1. Derivative of constant will be equal to 0 divided by function 3x square minus 2x plus 1 times ln of 10. So in this way, what will be the answer? It will be 6x minus 2 divided by 3x square minus 2x plus 1 times ln of 10. This is the final answer. Now, this is about common log and other bases, like not e, but if we have natural logarithmic function. So in case of natural logarithmic function, ln of let's say 3x square plus 1. So what will be the derivative of this one? We know that for this we use this rule, like that, derivative of f of x divided by f of x. So here f of x is this. So derivative of this will be 3 times 2x plus 0, because derivative of constant 0, divided by 3x square plus 1. So that will be 6x over 3x square plus 1. This is plus 1. So this is the final answer. In the same way, if you have need to find the derivative of ln of let's say any function, something x is power 1 by 2 plus 3x minus 1. So again, what will be f of x in this case? F of x is, in this case, this one. So derivative of this, when we want to find, like derivative of x is power 1 by 2 will be equal to 1 by 2 power rule. 1 by 2 decrease 1 in power, and then plus derivative of 3x will be equal to 3 times 1 minus derivative of constant 0 divided by function as it is. So in this case, this will become 1 by 2, and we know that 1 by 2 minus 1 will be equal to 1 minus 2 by 2, that will be minus 1 by 2. So it means that x is power minus 1 by 2 plus 3 divided by x is power 1 by 2 plus 3x minus 1. So this is the answer. And this is very important. Keep in mind, if you take the derivative of ln of x, so we know that derivative of x will be 1 over x. But if you have need to find the derivative of log of ax, that will be equal to 1 over x times ln of a. After that, we have derivative of, we have need to find the derivative of trigonometric function. We know that we have 6 trigonometric functions, that is denoted by sine of x, that is sine of x. Actually this sine x, cos x or tan x are the ratios of right triangles, right? So sine x, cos x, tan x, and its reciprocal of sine x will be cosecant x, and reciprocal of cos x is secant x, and reciprocal of tan x is secant square x. So in this case, like if you want to find the derivative of this function, like if you want to find the derivative of sine x, that will be equal to minus cos x. Sorry, derivative of sine x will be equal to cos x, but derivative of cos x will be equal to minus sine x. In the same way, if you take the derivative of uh, tan x, that will be equal to secant square x, right? But if you have other than x, keep in mind this is very important. Like if you have need to find the derivative with respect to x, but in place of instead of sine x, it will be a sine u will be a function of x. So what you will do in this case, it will be equal to sine derivative sine. Now that this will convert into a cos u times the derivative of u. This is important. Like in this case, you will also take the derivative of u. For example, you have d by dx sine x k. So what will be the derivative of this one in this case? So see that in this case, this will be equal to sine will be convert cos x k, and derivative of x k. Like don't forget, take the derivative of angle. So in this case, this will be cos x k times derivative of x k will be 2x. So that will be 2x cos x k. In the same way, like if you have need to find the derivative of cos of u will be any function. So in this case, it will be minus times sine of u times derivative of u. For example, like if you have need to find the derivative of cos of 2x plus 1, something like that. So in this case, u is 2x plus 1. So see that cos will be first of all converted into a minus sine u, that is 2x plus 1, and take the derivative of 2x plus 1. So we know that in this case, this will be minus sine 2x plus 1 times derivative of 2x will be equal to 2 times 1 plus 0. So that will be equal to minus 2 sine 2x plus 1. After this, we have need to find the derivative of, let's say, tan x. Instead of tan x, it will be a tan u will be any function. So in this case, it will be secant square u times, sorry, this is u times derivative of u. For example, uh, you have need to take the derivative of secant, sorry, tan. You have need to take the derivative of tan 2xk plus 1. So how we find the derivative of this one? For this, tan will be convert secant square, and this u will be as it is in this case, like 2x square plus 1. And don't forget, take the derivative of 2x square plus 1. This is also called as actually chain rule. So when we take the derivative of like first of all secant square 2x square plus 1 as it is, and when we take the derivative of 2x square, that will be 2 times 2x plus derivative of constant 1 is 0. So we will get 2 multiplied by 2 4. So it will become 4x secant square 2x square plus 1. That is the answer. In the same way, Like if you have need to find the derivative of its reciprocal d by dx of, let's say you can say that um, after 10 we have cosecant x, so that will be equal to minus time cot x into cosecant x. And in the same way, if other than x, like angle is other than x, let's say u, so it will be minus cot time u or cosecant u time du by dx. For example, if we take example, then you will understand better. For example, uh, if we have need to find the derivative of cosecant uh, 2x square minus x plus 1. So in this case, we know that what is the rule? Rule state that if you have need to take the derivative of cosecant u, that will be equal to cot of u minus cot of u cosecant of u time du by dx. So in this case, it will be minus cot of u is equal to 2x square minus x plus 1 time cosecant of u, that is 2x square minus x plus 1 time the derivative of its angle, that is 2x square minus x plus 1. So it will become minus cot 2x square minus x plus 1. That will be as it is cosecant 2x square minus x plus 1 as it is time the derivative of 2x square, like this will be 2 times 2x minus 1 plus 0 when we take the derivative of this term. So finally, our answer will be minus 4x. We will write this term first, minus 1 and 4 2x square minus x plus 1 cosecant 2x square minus x plus 1. So this is the final answer. In the same way, we have note space, we can write here, no problem. In the same way, if you have need to find the derivative of secant x, reciprocal of cos, so that will be equal to secant x tan x. And if you have in the same way secant u, that will be secant u tan u times the derivative of u with respect to x. So we give one example, then you understand better. For example, if you have need to take the derivative of secant, mm, secant, let's say secant x is power 3 minus 2x plus 1. So what will be the answer of this one? Now in this case, see that this is other than x, like this is a function composition. So in this case, first of all, secant will be converted like by using this rule. Secant x cube minus 2x plus 1 times tan x cube minus 2x plus 1 times the derivative of inside function, that is x cube minus 2x plus 1. So in this case, this will be as it is, and tan x cube minus 2x plus 1 times the derivative of x cube will be equal to 3x square. Derivative of minus 2x will be equal to minus 2, and derivative of 1 0. So this term we will write first, that will be 3x square minus 2 times secant x cube minus 2x plus 1 as it is, and tan x cube minus 2x plus 1 as it is. This is the answer. And the last one, that is a reciprocal of tan, that is cot x. So this will be equal to minus time cosecant square x. So in this way, if you have cot u, that will be minus cosecant square u time du by dx. So for example, like by this way, we will take derivation. For example, mm, if we have d by dx of cot x square plus 3x minus 5, something like that. So in this case, we know that derivative of this one will be found by this way. So this is actually chain rule. So in this case, derivative of cot will be minus cosecant like x square plus 3x minus 5, and derivative of inside function, that is x square plus 3x minus 5. So final answer will be minus 5, and derivative of x square will be 2x. We have find derivative. Derivative of 3x will be 3. Derivative of minus 5 is 0. So we will write this term first. 2x plus 3. Negative will be as it is. X square plus 3x minus 5. So this is the way out how we'll find the derivative of cot function. After that, one important thing is that, like, keep in mind, if you have sine square x dx, so its derivative will be, first of all, you apply power rule. But you have need to apply power rule. That will be 2 times sine x 2 minus 1, and take the derivative of base in this case, that is sine x. This is important. Keep in mind, here you will use first this rule, because power on a sine, like on a function. So whenever you have a power on a function, you will apply power rule. So in this way, this will be 2 sine 2 minus 1 will be obviously x. Derivative of sine is cos x. But if you have something like that, sine x square, so see that in this case, first of all, you will apply, like this is a composition. Sine will be convert cos x square, then take the derivative of x square. So in this way, derivative of x square will be 2x. So we will write it here and cos x square. So this means that sine square x is not equal to actually sine x square. So this is a power on angle. This is a power on a function. So be careful. In the same way for cos, tan, or any function. After this, we have inverse trigonometric functions. Like in inverse trigonometric functions, if you have need to find, we know that some inverse trigonometric function is sine inverse of x. And there are 6 inverse trigonometric function: cos inverse of x, tan inverse of x, and then reciprocal of sine inverse is cosecant inverse of x. Reciprocal of cos is secant inverse of x, and reciprocal of tan is cot inverse of x. So same way, if you need to find the derivative of these functions, like if you have d by dx of sine inverse of x, that will be equal to 1 over square the root 1 minus x square. But if you have d by dx of cos inverse of x, sorry, this is cos, not cot, cos inverse of x, that will be equal to square minus times square 1 over square the root 1 minus x square. In the same way, like if you have need to find the derivative of tan inverse of x, that will be equal to 1 over 1 plus x square, right? And after that, if you have need to find the derivative of reciprocal of sine is cosecant inverse x, that will be equal to minus time 1 over x time x square minus 1. And in the same way, if you find the derivative of reciprocal of secant inverse x, that will be equal to minus time, sorry, this will be a plus. Wait, 1 over x times square the root x square minus 1. And the last one, that's the reciprocal of cot x, sorry, tan x, that is cot x, cot inverse of x. Reciprocal of tan inverse of x is cot inverse, that will be minus 1 over 1 plus x square. So in the same way, like if x, this is very simple, but if you have something like that other than x, like d by dx of sine inverse u, that will be equal to what? Like 1 over square the root 1 minus u square time du by dx. Obviously this is multiply here, so it goes up. So u will be any function. If we do one example, then you will understand better. For example, you have need to find the derivative of sine inverse any function, let's say 2x plus 1. So what will be the derivative of this one? 1 over square the root 1 minus this u. In this case, u is 2x plus 1. And then take the derivative of u, that is 2x plus 1. So in this way, what will be the answer? Here is a square, u square, like d by dx sine inverse u is actually equal to 1 over square root 1 minus u square du by dx. So derivative like this will be 2x plus 1 whole square. No need to open the square. It will be keep as it is. And 2x, what is the derivative of 2x? That will be 2 times 1 plus 0. So final answer will be 2 over square the root 1 minus 2x plus 1 whole square. In the same way, any inverse trigonometric function, let's say sine inverse. And here you have something, let's say inside logarithmic function ln of x. So what will be the answer in this case? Same. First of we apply this rule. 1 over square the root 1 minus u, here is ln of x, and take the derivative of ln of x. So in this case, we know that derivative of ln of x. So we need to apply this rule, ln of f of x, that is equal to 1 f prime of x over f of x. So derivative of this function will be 1 over x, right? So in this way, our answer will be 1 over square the root 1 minus ln of x whole square time 1 over x. This is the answer. After that, second one, like if you have cos inverse, and here you have u, so it will be minus times square the root 1 minus u square du by dx. This is dx. So let's take one example so that you understand better. For example, if you have need to find the derivative of cos inverse 5x square plus 1, this is something like that. So you need to apply the rule. We state that like d by dx of cos inverse of u is actually equal to 1 over square the root 1 minus u square minus time du by dx, right? So u here is in this case 5x square. So minus time 1 minus 1 over square the root 1 minus u is 5x square plus 1 time the derivative of u, that is 5x square plus 1. So in this way, what we will get? We will get minus 1 over square the root 1 minus, here is a square. So 5x square plus 1 whole square, and derivative of 5x square, that will be 5x square by power rule 2x, and derivative of constant 0. So this will become actually minus 10x, like 5 multiplied by 10 over square the root 1 minus 5x square plus 1 whole square. Okay, in the same way, like if you have need to find the derivative of cos inverse, here will be any function like for example, in this case we take e raised to the power x plus 1. So this means that u in this case is this. So by applying above rule like this formula, so it will be minus 1 over square the root 1 minus u in this case is ex plus 1 whole square, and take the derivative of u, that is e raised power x plus 1. So in this case, what will be the answer? Minus 1 over square the root 1 minus ex plus 1 whole square time, like taking the derivative of exponential function, we know that for this e raised to power f of x derivative is equal to take the derivative of f of x time e raised to power x. So in this case, we know that derivative of e raised to power x, if we take power is x, so derivative of x 1, so derivative of e raised to power x will be equal to e raised to power x, and derivative of constant will be 0. So final answer will be minus e raised to power x over square the root 1 minus e raised to power x plus 1 whole square. In the same way, next one, if you have tan inverse, so d by dx tan inverse, and here you have u will be any function, so in this case it will be 1 over 1 plus u square du by dx. For example, I will take one example, then you understand better. For example, you have d by dx tan inverse square root of x. So don't worry, square root of x can also be written as x raised to power 1 by 2. So this means that it will be equal to 1 over, because we know that the rule, d by dx of tan inverse u is equal to 1 over 1 plus u square du by dx. So 1 plus u in this case is square root x. Square time the derivative of u. So keep in mind, square root of x can also be written as x is power 1 by 2. So you can easily apply the infinite power rule. So 1 over 1 plus, in this case, easily cancelable. So you can write it as like that. And here it will be written as x is power 1 by 2. So by power rule 1 by 2, x is power 1 by 2 minus 1. And this will become 1 over 1 plus x time derivative of this one, 1 by 2 x is power, see that 1 by 2 minus 1, when we take the LCM it will be 1 minus 2 over 2, that will be minus 1 by 2. So minus 1 by 2. So you can write it as something like that after simplification. This is just simplification. 2 times 1 plus x time x is power 1 by 2. Because this is a negative power, keep in mind minus 1 by 2 can be written as 1 over x is power 1 by 2. So this is the simplification. If you write here above, there is no issue. But because this is easily simplifiable, that is why I write it as like that. Either if you have something like that, you will apply the same rule, tan inverse, let's say 2x plus 1. So in this case, it will be again 1 over 1 plus u square means 2x plus 1. This is not x square, this is 2x plus 1 square, right? And take the derivative of 2x plus 1. So in this case, it will be derivative of 2x will be 2 and derivative of constant will be 0. And this will be written as 1 plus 2x plus 1 whole square, and derivative of 2x is 2 and derivative of constant is 0. The final answer is 2 over 1 plus 2x plus 1 whole square. This is the answer. After that, next one is cosecant inverse. So when you have cosecant inverse, in this case, cosecant inverse u can be written as minus 1 over u time as it is x. Square the root u square minus 1 time the derivative of u with respect to x. For example, if you have function like that, uh, cosecant inverse 3x square plus 1. So in this case, we apply the rule. We state that it will be equal to minus 1 over u time like 3x square plus 1. Square the root u square, that is 3x square plus 1 square minus 1 time the derivative of u, that is 3x square plus 1. This is actually in this case u, and we apply actually this formula. So it will be minus 1 over u times square root of u square minus 1 du by dx, right? So we can write it as minus 1 over 3x square plus 1 times 3x square plus 1 whole square minus 1, and time the derivative of 3 will be as it is, derivative of x square will be 2x and derivative of constant will be 0. So in this case this will be minus 6x over 3x square plus 1 and square the root 3x square plus 1 whole square minus 1. So this is the way out how we will take the derivative of cosecant inverse, and here, like, instead of x, that is you will be any function. In the same way, like if you have need to find the derivative of secant inverse u, that will be equal to 1 over u times square the root u square minus 1. And don't forget, take the derivative of u with respect to x. So I think you can do that. Now you understand the process. For example, like if we take one example, if we have d by dx of secant inverse, let's say here we have ax plus 1. Like again, inside we have a function. This is actually considered as our u. So by formula, state that 1 over u, that is ax plus 1, times square the root u square, that is ax plus 1 whole square minus 1, and take the derivative of u, that is a raised power x minus 1. So here, for taking the derivative of this ax, keep in mind this formula. Recall this formula: a raised power f of x is equal to f prime of x ln of a raised to the power f of x. But in this case, we can see that a raised to the power x can be written as derivative of x is with respect to x is 1, and it will be written as ln of a raised to power x. So this means that it will be 1 over a raised to power x plus 1 as it is, time a raised to power x plus 1 whole square minus 1, time the derivative of a raised to power x will be ln of a raised to the power x minus derivative of constant 0. So the final answer is a raised to power x ln of a over a raised to power x plus 1 times square the root a raised to power x plus 1 whole square minus 1. In the same way, for example, like we take one more example, little bit easy, so that if x square plus 1. So in this case, again, we have need to use this formula, like secant inverse u will be 1 over u times square the u square minus 1 du by dx, right? So for this, u in this case is x square plus 1. So this means that it will be 1 over u is x square plus 1 times square the root u is x square plus 1 whole square minus 1, and times du here is x square plus 1 over dx. So the final answer will be derivative of x square, like 1 over x square plus 1 times square the root x square plus 1 whole square minus 1, and derivative of x square will be equal to 2x, derivative of constant will be 0. So final answer will be 2x over x square plus 1 times square the root x square plus 1 whole square minus 1. This is the final answer. In the same way, like if you have code, so you can do that. Now there is no issue. It will be minus 1 over 1 plus u square du by dx, right? Now, if you see that, very important thing is that, like, see that all in trigonometry and inverse trigonometry case, if you see that derivative of all function that start from c, they have a negative sign first, right? Also, like if you take the derivative of a code, so you will see that there will be also negative. In the same way, it start from C, have a negative sign. It start from C, have a negative sign. It start from C, have a negative sign. So this is a way out how we will find the derivatives of derivative of inverse trigonometric function. So actually today what we have did, we just revised the basic rules of differentiation, in which first of all, like if I give you a quick review, first of all we had discussed about that, like first of all we had discussed about that how to find like how derivative of constant is zero. After that we did some example, then power rule. In power rule we have two types, like generalization and in particular. After power rule, we discuss about some examples and constant multiple rule. Like if you have any constant multiplied by a function, so we keep the constant out of the derivative and take the derivative of function. After that, we discuss about the sum difference rule, how to find the derivative of sum difference of a function. And then we discuss about the product rule, like two function if occur in a product form, how we find the derivative. Then quotient rule, like if two function given in a quotient form, how we find the derivative of these two functions. And chain rule, like if two function in a composition form, how we'll take the derivative of these function. And derivative of exponential function, like two type of exponential function. One is natural exponential function, other is if base is not equal to a. And we know that exponential functions are the function in which power pair as a variable, and in base we have a constant number. After that we have logarithmic function, again two type of logarithmic function, common log or natural log, and log with base not equal to e. This is something like that. So again two formulas we have, like this and this. And then we discuss about some example, like application of this formula. This is very important, like taking the derivative of this. After that we discuss about the derivative of trigonometric functions, six trigonometric functions and six inverse trigonometric functions. So this is all about very commonly used uh, rules and function whose derivative we have need to take in calculus. Hopefully you understand this. If you think understand this, so thank you so much. And if you want to take tutoring like A level, O level, or higher mathematics like calculus or other any mathematics subject, so you can contact me like +92 306 191 0066. So you can WhatsApp, and you can also contact me on in a inbox. And also I have an email. You can also mail like Muhammad Umar tetra 0 tetra 4 @gmail.com. So best of luck. Have a good day ahead. May Allah give you a success in your life goals. Bye bye.